This conference will now be recorded.
Okay, I'll now pass you over to Stuart, who will start the presentation whenever you're ready, Stuart.
Thank you. Thanks for the introduction, and thank you for the invitation tonight. I'm going to run through I'm going to run through a video that we filmed through the 78-hour possession at Lynebeg and Moy. But before I do that, I wanted just to share a couple of links with Transport Scotland. So I'm not sure if any of you have seen this. I'm going to play it straight from the YouTube link. So hopefully it will work in 2 seconds when I share my screen. 1 second. Can someone just confirm that my screen is shared?
You can see it now, yeah.
Yeah. Thank you. So I'm just going to run through the fly-through for the A9 section that's adjacent to the railway in the Moy and Highlands where we were working. So I'm just going to pause it there for a second. So, you know, the project that we were undertaking is the early interventions for the A9 dualling work at the Tomatin and Moy section, which has been promoted, as you all know, by Transport Scotland. The project hierarchy would be Transport Scotland, AMJV, the joint venture leading this section of the work, Network Rail, and BAM Nuttall as principal contractor. So you can see the structure of this section here, which we're going to discuss today, but also as part of this work we were undertaking some culvert work as well. So I'll just finish this off here. So it's quite a small settlement of houses at Moy. If you know the area, there's a small section, small population in the area of the work. So as part of this grade separation junction, they're creating a new access into Moy and closing the south access into the village and creating this new main access. Now, unfortunately, that places the majority of all of our work during this part of the contract in this very constrained area in front of the houses. There is another cottage here. So it creates a really logistical challenge in terms of how we get the plant machinery and in fact the bridge into place. Now that, and there was a lot of preliminary work which I'll come back to a bit later in the presentation. So try and then just to try and give you a kind of on the ground look, that is the main compound at the time of mobilisation. You have Loch Moy in the background, quite a big, it was taken there adjacent to the houses, and this is the area in here where we constructed the concrete portal structure, and then we had our offices and main compound in here. And you can see here is this is the location of the railway section of the Highland Main Line and the small stone arch bridge that was going to be replaced. There was nothing essentially wrong with the structure. It's just been replaced with a highway spec concrete portal structure for the new A9 access. 1 second. Okay, can you see the slides? Someone can confirm, that'd be great.
Yes, Stuart, that looks perfect.
Yeah.
Thanks. So the title, Battle in Storm Arwen, was largely where we hung the story on the press release at the end of it. So those of you that we're around at that point. Yeah, not what you want in the start of a 78-hour possession is to get the weather forecast that we had with Storm Arwen. Yeah, it was a really challenging set of weather circumstances for the team to deal with. So I'm going to just run a quick video here so that you can all see it. Some of you may have already seen this, but it'll give you an idea of what we were dealing with.
Half a teaspoon burns fat 728% faster. Before you go.
So there's a little, sorry about that, folks.
We're here at Moy on the Highland Main Line carrying out a bridge replacement. We've went for a disruptive possession here, which is 78 hours, due to the timescales and the complexity of the bridge replacement. So the structure you can see behind us, we've been building that throughout the summer in an offline position. That allows us to construct it in its entirety without impacting the infrastructure. We're utilising specialist equipment to drive the structure into its final place.
Here today we've got people from right across our transport sector. We've got highways, we've got our Rail South team, and we've got our Rail Scotland team all pulling together to get this bridge into place.
Later on next year, sometime about October, we've got a big SPMT pre-box build that we got in Birmingham, which we want these guys to help us with. So, you know, coming up here and getting that relationship, building that support and understanding how they operate and seeing what they do is great for us, and we can share that knowledge and bring them into what we're doing. Great team of guys working well together. You know, Rail South are up there supporting the BAM Scotland, which is great. Great to see that alignment, that integration to sort of build them integrated delivery teams.
So we've got a great team here from Mammut who are operating the SPMT to transport the bridge in. A lot of commitment from everybody to get this bridge into place. We're midway through our 78-hour possession on the Highland Main Line. We've suffered winds, gales, 80-mile-an-hour gusts, snow, ice, rain, all seasons in the first half of the possession, but we've now got the structure in place and we're now loading in the wing walls and lifting them into position. While our focus has been on this main structure to the south, there are two smaller culverts that have been installed, and there's been a lot of hard work there. That's very exposed, open on the hillside, and they've faced some very challenging conditions there. And what they've achieved over this weekend is fantastic. So the culvert team are really pulled together to get those culverts in.
Great to see the bridge in place and to see the first passengers back on the Highland Main Line.
Before you go to bed tonight, eat 1/2 teaspoon of this before 10.
Stuart, you're still on mute. Sorry.
Yeah, so I hope you all have 1 teaspoon of that before you go to bed tonight. Yeah, so I want to do is, can you see the slides again now?
Yes. Yeah.
Yes, thank you. So yeah, we talked about the weather there. As we approached the start of our 78-hour possession, we were hit with that weather event. But there was a real significant risk of a possession cancellation. You know, we really had to consider the safety of the team and all the people that were coming to support the delivery of the work. So, you know, while we hung our press release on the battle in Storm Arwen, actually the real consideration was, is it safe to go ahead and deliver the work? I mean, the weather forecast was a bit erratic going into Arwen, and we had, you know, if we'd been going to face the weather that the far northeast of Scotland had faced, it would have likely been a cancellation and quite a significant hit for everybody involved in terms of delay and cost. But yeah, the decision was made that we looked like we were going to miss the worst of it. I was there on the Friday night trying to put up put in additional measures to help, you know, provide additional welfare and protection from gusts of wind, with the team support that. But I mean, we were I've worked across Scotland and I've lived in the Highlands all my life, and it was pretty wild up there, particularly down at the culverts, which are open in the kind of moor there. The wind coming down off the hill was definitely gusts of 80+ miles an hour and blizzard conditions. But it settled as we went into the start of the possession. Was actually midnight on the Friday, so we didn't lose a lot of time from that initial kind of storm weather, but then sporadic snow, very cold conditions, you know, temperature going up and down throughout the weekend. But I think, you know, in assessment, the team were happier to have snow than rain, particularly because the water table in that area is very high, so you don't have to dig very deep in Moy to find water. So we had a big risk in terms of the delivery of the project, because we had to dig down after the demolition of the structure to build up the foundations of the bridge. So yeah, there's a real risk. If we'd had a lot of heavy rainfall, we would have had probably a bigger risk in terms of you know, delay to the project of pumping and such like. The contingency measures during that were actually essential, and I think as you go into these possessions, you quite often think, oh, we always put that contingency and we never use it. But we had local contractors in place with snow ploughs, critters, which were on call, and we had to call them out on the Friday. So yeah, I think it was one of those jobs where you're happy to have the contingency in place. And I think late into the Saturday morning, a tree came down over the road, which would have blocked the next shift coming in. And again, we had local contingency contractor in place to come and clear that. So yeah, tough start to the possession, but actually, as we went in there, we weren't putting anybody at risk in terms of the weather, the conditions that they were facing. Yeah, so I put the links to the two videos that I've shown in the bottom of the slides there, so we issued them. So we've got the structure here and the core delivery team there on a safety. In fact, one of them's just arrived. Caleb's just arrived. So yes, this is the old stone arch structure that we were replacing with the concrete portal. In terms of a project timeline, I guess the key thing that we've taken from this project was, you know, it was a lot of early engagement with Transport Scotland, AMGV, Network Rail, and a range of other stakeholders linked to the job. And it was over an 18-month development phase, very important to de-risk the project. And if you look at the image in the top right-hand corner, you know, that was us in peak delivery. There's two 750 cranes either side of the structure, but to get the structure there, you had to move the structure down before you could rig the second crane. So the very limited space to work. The railway is a barrier on one side, and the residential properties and a burn on the other side down here. So very limited space. It was very much a lot of planning and logistical challenges in terms of the methodology and how they would approach that. So yes, a lot of work done by the team in terms of trying to sort out that order of construction. The site investigation was in 2020, and then into 2021 there was a full mobilisation of the main work in February last year. And then in spring we went into enabling works. There was a lot of enabling works in terms of utility diversions. The road, the camber on the road, the camber leans towards the houses, and to get the SPMT to transport the bridge down, they had to change the gradient of the road. So there's a lot of continual roadworks right through that period in terms of whether it was utility diversions or changing the camber in preparation for it, and we had to protect and almost pirouette around some of the services in that area. We're also installing a UTX. Now, originally there was to be 2 UTXs to be tunnelled in with a mini TBM, but through that kind of engagement and through the kind of, cost reduction with the team, they were able to actually reduce that to 1 UTX, and the permanent UTX was installed and acted as the temporary utility diversion. So a good bit of cost saving creativity there with the team. In spring, we also mobilised in on the Culverts job to take best use of the finer weather to get access in and get ready for the earthworks in and around the culverts. Summer 2021 was largely focused on the construction of the concrete portal structure and casting of the wing walls, and that was completed in September. In 2021 autumn, it was really about readiness, getting ready for that possession that we had coming in, going through the readiness reviews, you know, looking at every bit of detail and planning out the 78 hours. Yeah, and then into the 26th, the 29th was the 78-hour disruptive possession, which you've just seen the video on. January, and in 20, and now we're into this sort of finishing stage. We're using the original granite has been split and dressed to act as cladding on the new concrete structure, which is quite unusual for a rail structure. Certainly not seen many of them that will be being clad, and yeah, we're using the existing granite to do so. Yeah, so that works, and landscaping will take place in March. So yeah, a lot of work still to do. I just want to share an image of the culverts there. You know, and this is one of the main culverts, which is further down the track. Robert will talk a little bit about the track when he comes on to do the PWI section of the presentation. But yeah, so this is down at the south end of our working site, and very much open to the moor. So if anybody was battling Storm Arwen, it was the team down at the culverts that faced the brunt of the weather. Yeah, just again, you can see the constrained site there. So really difficult site to manage safety on, and you know, control that, and you know, Huts a ground of applause to the effort that they've put in there. One of the things that I quite liked was the fact that they managed to maintain a lot of the training and development during the pandemic. So they did safety training. You can see them there with the air-fed masks, doing training and doing a safety day. There was predict and prevent exercises, and then work package plan consultations, and again working in a very constrained environment. And we thought, as he talked about the weather, the outturn of that was no accidents. You know, nobody was hurt during the course of the work, I think, which is always our aim. But yeah, in a very challenging, constrained position, that's always what you want to come out of. I'm going to pass on to Robert now to cover the PWI section, which I'm sure you're all interested in. I don't think it's got a huge amount of work in it, but Robert, I'll control the slides if you want to let me know when you're ready.
Yep, hi everyone. I think most of you know me, so I will talk you through the PWI works that were undertaken during the 78-hour possession. I like to put animations in the slides, so we'll see if Stuart and I can coordinate this between us. The picture that's in front of you there is me standing in the forefoot just to the south of the underbridge. You can see the handrails just up in the distance a wee bit. You can obviously see my spray mark of where the track has to start coming out. As you can see, narrow embankment. Stuart, if you want to first click, I think. Yep, so on the bridge 86, as you can see, single line with F27 sleepers, 113A rail. I guess the most constraining part of it was a pretty high embankment with an RSS either side. The photo there shows me standing pretty much on the bridge. And another interesting thing to note for the next slide is that the entry to Moy Loop was just up in the distance, 260 yards away. This is me here standing at the south culvert. So the two culverts that we had to put in were at approximately the 101 3/4 mile post and just south of the 102 mile post. The track at the culverts G44 sleepers with again 113A rail. So whenever the sleepers were put in, they must have put the old rail in because it was pretty old, 1980 or something. That rail there is from. At that culvert in front of us, one of the challenging things was the signal and all the cables just up ahead. These all had to be disconnected to allow us to take the panels out, which gave us a bit of a headache at the end of the possession. Next click, Stuart. So during the Grip 4 design for the bridge, I'll focus on the bridge in the next couple of slides. Stuart, if you do the next click, the contract specific requirements for the site asked that we consider future proofing for the line in the area. So the track design should extend the existing Moy Loop south. Provide a new NR56 FES 24 right-hand turnout, providing at least 640 metres of standage. The design should be future-proof for 100 miles an hour in track category 2, and the loop would remain at 40 miles an hour in track category 5. Next click, Stuart. So if you think back to the previous slide where I was standing on the top of the embankment in the forefoot, you could see that on the right hand side, not a lot of space. The road was just at the bottom of the embankment. So when we were considering options for the future proofing, if you like, go into it, and our first thought is, well, what's easiest for the PWA? So as Moy Loop, the entry to Moy Loop is a right hand turnout, then by far the simplest solution for the PWA would just have been to remove that turnout, extend the loop line further south as shown on that little diagram, and put the right hand turnout into the existing single line. But the problem that gave us is, next click, Stuart, is that that PWA solution isn't what had been anticipated with the bridge design and with the A9 design. And given that the A9 and the dualling, if you like, was the bigger project, is that the reason that we were all here, then unfortunately the easiest PWA solution wasn't the best solution for the site. It would have meant having to redo the Form 1 for the structure, and it would also have meant significant earthworks retention alongside the B9154. If you do the next click, Stuart, I think I've got a photo comes up. So as you're standing there, if you can imagine, the easiest PWA solution would be to keep this as the main line, put the loop off to the right. But if you imagine a 1976 foot and then a 1435 gauge and then another couple of metres for your cess, you're pretty much going to be out at the, in line with the road there. So you would have also almost had vertical retention right the way along the road, which would obviously have been very expensive, time consuming, and I guess would have taken away from the fact that, as Stuart showed in his initial video, the real reason for doing the bridge was for A9 dualling. Next click, Stuart. So we then looked at another option, which was a second PWA option, which, if you like, is shown on the screen there. Next click, Stuart. You still have a right-hand turnout, if you like, at the south of the bridge, but to get that right-hand turnout in the correct position, we have had to slew the existing single line across significantly. You can see that at the bridge, the loop line is in the position where the existing line is, and the new main line would be off to the left. And you can see that up at the roughly chainage 165575, where the existing Moy loop entry is, the two new lines end up like kind of either side of the points up there. So this option required much more PWA work, but it meant that the Form 1 bridge design could remain unchanged. And it also meant that the possession strategy that we had, the 78-hour possession, would still be valid, because ultimately the bridge work and the earthworks that had always been anticipated would stay the same. So the option 2 there that was in the grip 4 is the one that we ended up developing into the, if you like, the single option and the preferred alignment. Next click, Stuart. And just as an idea of what that option 2, so the one that we ended up developing, if in the future Moy loop was extended as per the option 2, you can see that at the south end where the new points would be, the existing single line would have to be slewed 1.5 metres. Next click, Stuart. At the bridge, you can see just on that design there that an existing single line matches up with the new loop line in option 2. Next click, Stuart. And with the option 2 design, the maximum slew to take, if you like, the existing single line position to be the new main line was a slew of 4.2 metres just to the north of the bridge. So obviously, if this job did happen, there's obviously significant earthworks, both south of the existing bridge and north of the existing bridge. So I guess if it ever happens, extending Moy loop is another massive piece of civil engineering and also PWA works. And next slide, Stuart. Or next click, sorry. And what I've circled there is where the toes are for the existing entry to Moy loop. So basically just to show that, with the design that was taken forward, that it wasn't possible to tie it back in before the loop. The PWA works extend a good 200 metres into the loop, so the loop and the main line having to be replaced. Next click, sure. So as we move forward into the grip 5, the Form B detailed design, we had fixed on an alignment. So that during the detailed design, a big part of it was interfacing the PWA with the civils Form 3 detailed design. I've shown there a cross section from the PWA design in the grip 5. Things to point out. I've got some points that will come up, Stuart, if you just want to click. Oh, sorry, do you want to go up one? Maybe, yeah, things to point out on there. You can see that there is a 250mm sub-ballast, so capping layer on top of all the earthworks fill. That was to achieve 60 kilonewtons per millimetre track bed stiffness. The existing F27s were replaced with G44s with undersleeper pads over the length of the full dig. The F27s were reused on the ballast ramps. The ballast ramps that we provided were 16.67 metres long, so suitable for 100 miles an hour. And the ballast depth provided was 300, so again, future proofing for 100 miles an hour. Yeah. As far as the re-railing was concerned, we got a long wheel gauge rail delivered to site, 216 metres that we cut in half. So basically the full job was covered by one bit of rail on each leg, meaning we only had 4 welds. Another point to note is that the embankment was widened, but only local to the bridge to suit the future double track layout. And again, I've provided a section there which shows what the embankment fill and what the embankment layout looked like very locally. So it was only like that for perhaps 10 metres either side of the bridge. Again, that means that in the future, if a new or an extended boiler was to be provided, then the second track could just get put on the left-hand side there. Next picture. When it comes to installation, as always seems to happen, I looked back at all the photos of the installation and couldn't find any good ones of the PWI works, mainly because during the bit that we're all hands-on, you get plant everywhere and people everywhere, and the photos don't look very good. So the best photo that I could come up with was that one there, which is the bridge in its final position. They've started backfilling up underneath the bridge, but you can see on the left-hand side there, at that point anyway, we hadn't started doing the backfill behind the abutment, and I feel like the slope is still there up to where the track was left in. Problems that we encountered during the installation for the PWI work, not many to be fair. If you do the next clip, Stuart. Well, we've spoken about the weather, how that impacted us with the PWI. Unclipping at both the culverts and at the bridge became almost impossible because, as well as snowing, if you like, during the possession, it had been snowing in the week beforehand, but getting warm enough during the day that the snow would start to melt. So around all the clips was basically a big block of ice that the full way along the length of the job. It became almost impossible to unclip fast clips and pandrels, but not doing it wasn't an option, and I guess most of us know how vulnerable fast clips housings are when a bit of force is exerted on them, usually with hammers. So we ended up having quite a few damaged fast clip housings as a result. On the Monday evening, so about 9-10 hours before the possession was due to be handed back, everything was going smoothly. The track was in, the top ballast had been dropped, the tamper had finished at the culverts, it had come up to the bridge. We were pretty happy that everything was going to go smooth. We were all getting ready for an early bed for a change in a possession, but the tamper lining wire snapped, and I've taken a screenshot there from the fires report. They didn't actually have a spare lining wire that was long enough, so they had to go through a bit of a process of cobbling together the one that had snapped with the new one, and then cutting them to make them fit. So that took just over 2 hours, I think, if memory serves me right. So you can imagine most of you have probably been in a disruptive possession. It's 10 hours to go, 8 hours to go, 6 hours to go. At 8 o'clock on the Monday evening, everybody had been relatively happy, and by 10, half 10, it was almost full-scale panic with people phoning every 5 minutes. What's the update the lining wire? What's the update the lining wire? What's the update the lining wire? And it gets to a point where all this money and all this brilliant work that's happened risks being undone by the tamper not having a big enough spanner on it, but fortunately we got the tamper working again, and when it did, it didn't actually have much work to do anyway. The sleepers and the ballast had all put in reasonably well, so managed to get it done in plenty of time. Next click, Stuart. And then I guess another interesting one for the PWI, and really this one's on me. I didn't realise it when I was planning the job. I guess most of us know about CRT and stressing and temporary joints. So when at the end of the possession, the bridge was left with the 4 joints with a set of clamps on them, but due to the reasonably good access that you get up there, we had planned to do the welding 2 welds the next night, and then the stressing. In fact, I'm wrong. It was the night after the possession we planned to do the welding and the stressing. But what ended up happening is, as part of the bridge and all the earthworks, 7177 also required us to set a baseline up and then do 7 days of monitoring afterwards. So the geoinfo engineers went out at the end of the blockade, put 300 metres worth of targets on, took the baseline, and what then happened is the next night, you know, everybody wants to get the stressing done, to get the temporary joints taken off. The next night, the PWI subcontractor comes out and starts knocking clips out everywhere, putting the rails up on rollers, pulling the rail, and because it had been really cold when we put the rail in, it was quite a big pull. So you basically then end up in the position where all the targets that were put on are either missing or in a different position to where the baseline had been. What then had to happen is in day 2, after the blockade finished, they have to go out and fix targets and re-baseline everything. And what it actually meant is, if you like, the first comparison we had between a baseline and a set of monitoring figures was on the Thursday night. So the Tuesday morning we handed back, and it was really the Thursday night, Friday morning before we had a true, if you like, comparison between a baseline and a second survey. So just something for you all maybe to think about in the future. I guess a lot of us are used to prioritising getting temporary joints out and stressing, but in this instance, I certainly think that had I thought about it 2 weeks before the blockade, I would have told the PWI subcontractor to leave the stressing for 4 or 5 nights because of the amount of fill behind, you know, for the bridge and the capping layer and all this material that could potentially settle. I think in this instance it would have been much better to prioritise the track monitoring over the stressing. That might be me, Stuart. Yes, that's my last slide. Thank you, everyone.
Stuart, I think you're on mute if you get any more.
Yeah, we can move on to questions now.
Okay, well, firstly, thanks very much for that, both of you. It was excellent. If ever there was the benefit of looking at videos, it was in this case. I think the videos were excellent to show, you know, the severity of the weather and all the work that took place. We've got a few questions online. I was just going to make some observations for myself first, which was I thought it was also great that you had it shows the importance of having local contingency contractors available, because, you know, a lot of jobs have, you know, you might ask, have you got contingency? Oh yeah, we've got contractors in place, and then you find out they're 200 miles away, you know, and in your case, in such a bad storm, the chances of someone making it to the site would have been almost impossible. So that just shows you the benefit of having people local to be on standby for that. Yeah, absolutely.
We also had Highland Industrial Supplies. They close on a Sunday, so we had Highland Industrial Supplies open on the Sunday by request because of all the bits and pieces we knew we would need. So it's I guess that T- process, the readiness review that we go through, you know, really getting into what the requirements of the team are, and, you know, all the additional things that you don't know you're going to need until you need them. So having good suppliers that can provide that was definitely beneficial.
Yeah, absolutely. Just on that, you know, can you mention a bit about the criteria for the go, no go for going ahead? Because you know, the storm was hitting right at the start. So how close were you to pulling it, or what was the sort of factors that made it okay to go ahead?
I think it was well, we were just I wasn't involved in the discussion myself, but I'm aware that that it was very much looking at the weather pattern coming in. It was also considering people having to come up the A9 because some of the suppliers and subcontractors weren't there for the whole possession. They were coming up for parts of it. We had to consider, you know, is it safe to to ask people to come up the A9 if we think the A9 is going to shut. You know, and you know, we just monitoring Traffic Scotland, monitoring actually a Norwegian. Anyone that's from the north of Scotland knows that it's better to follow the Norwegian railway than in the Norwegian weather forecast than it is the Met Office. So we were monitoring the Norwegian weather radar, seeing what was coming in from the North Sea. And actually the local contractor, the local snowplow contractor, they've got access to quite a lot of detailed weather information, and they were giving us updates so we were fairly confident we were going to get hammered on Friday. That by the time we went into, you know, crane rigging and things like that, that we were going to be out of the wind, and the snow was a bit of a lottery. So
yeah, okay, yeah, excellent. Just a kind of one other comment from me, more for Robert, I guess. It was just, it must be quite rare occasions that you're asked to look at a track category 5, but to future-proof it for track category 2, 100 miles an hour. I don't think there's that many situations where that arises, is there?
Yeah, I think, Greg, the existence of the lines track category 4, it was the loop that was to remain at track category 5, but
okay.
Yes, it's one of those ones where, you know, you look at it and you think 17-metre ballast ramps, and what I guess normally when we look at bridges like this, and it wasn't that wide a bridge deck or anything, you know, it was, I'm looking at the civils drawn now, 12 metres, you know, and then maybe going back 10, 15 years, that 12 metres would have had a 9-metre panel either side, and you would have taken out 30 metres of track. But with the depth of the fill and the cut slopes, and then the 17 and 17 metres of ballast ramps for the bridge, we ended up having to take 100 and something like 103 or 104 metres of track out or something, you know. So it was, it became quite a big job, you know, when you're working on a single line on the high embankment. It was one way in and one way out with all the panels, with all the old panels, with all the new panels. So it took quite a bit of coordination.
Yeah, absolutely. Excuse me. Was there any need for DTS? Was that used at all?
No, we didn't use the DTS. No, I guess the fact that we had all this engineering fill and we were testing it on the way up, we were reasonably confident that by the time we got to the top, you know, before we put any ballast on it, that it wasn't going to go anywhere.
Yeah, excellent. Brilliant. I'm just going to take some of the questions in the chat here. So Angus was asking, can you describe the support method for the S&T? I presume he's meaning the cabling and such during the works.
Yeah, there was H beams were piled with a MOVAC into the embankment, and then there was a high tension cable run over the top of the H beams, and then the signalling cables were supported on the high tension cable. I think lesson learned on that, there were 3 high tension cables in place, and when it came to actually put the SPMT in, it was quite close in terms of the sag in the cable versus the parapet of the structure. So Mammut were able to lower the SPMT down, and then with a little bit of muscle, we were able to get the other millimeters and pull over the top. So yeah, lesson learned. As I guess it would have been better if the signalling cables on a higher tension cable.
Yeah, okay. It still sounds a pretty robust solution, though. You know, better than some pegs and nails and cables dangling off them. So yeah, excellent. Another one from Angus was, can you describe how the ballast was brought to site? Was it new ballast or reusing existing?
It was all new ballast. So NSC delivered it by road to our compound. It came from a local quarry. It was all, we created a big stockpile at the main compound and also a stockpile down at the culverts. On the night, it was delivered, if you like, to the cess using large civils plants, so big boxes. They would then unload it, and if you like, more traditional rail plant would then push it out. Dozers and kind of little 135 excavators and stuff like that, they would actually get it into position and doze it to its final level.
Yeah. Okay, that also ticks your carbon calculator boxes using a local quarry as well, definitely.
Yeah, so we're as you mentioned at the start, we're building a new loop at the station up at Inverness Airport. So the same quarry will provide, I think, the ballast for that job. You know, a much bigger quantity is required for Inverness Airport, which is a 3/4 mile long loop. So yes, obviously, it's good that it can come from there rather than Kingmere Yard in Carlisle or something like that.
Definitely, yeah. Okay, I've got a question here from Russell Kimber. He says, great presentation. What form of foundation is the main bridge superstructure sitting upon?
I'm going to sound like I know what. Sorry, Robert.
Well, I've been, when I saw that question come in, I've dug out the drawing that shows it, so I'll quickly share my screen and Russell will be able to see. Hopefully, hopefully that section will come up. Yes, yeah. So it's nothing fancy. It's you can see the key at the side, 6C fill. That's it. So it's just a case of back digging out, Russell backfilling, and I'm sure this is all the civils drawings, the specs. So I don't know them inside out, but there will be a specification somewhere of what stiffness we had to get at the bottom of that excavation and what stiffness we had to get at the top. So if you like, it doesn't actually show a dimension there, because the dimension was probably open-ended. That it would be dependent on what we find on the way down and what results we get as we backfill and compact it.
Yeah. Robert, it's Callum here. I can run through a quick brief of what we done on site during the dig. Site engineer that was on the job. So we had geotechnical engineers from Arup on call to the duration of the weekend. So they came up. We excavated down. We thought we were going to encounter some peat in some areas going by the SIGI. So we brought in additional 1,000 tonne of 6C material just to cover ourselves. But as it happened, we dug down, we found minimal peat. The geotechnical engineers, they assessed the formation and then basically said that was okay. That's as deep as we had to go. I can't remember what the actual final depth was. I think it was 1 metre in some places and 600 everywhere else. So yeah, that was a.
Yeah, thanks, Callum. Hopefully that's more than enough to answer your question, Russell. Hopefully.
I'm glad Callum did text me that, and I was going to have to read it out and pretend I knew what I was talking about. So thanks for your input, Callum.
Superb. Another, just a comment really from Angus, who says, great attention to detail, having access to HIS on a Sunday. It's obviously no mean feat.
Yeah, not the cafe though. Yeah.
One here from David Maxwell. He said, terrific to hear of the original granite being reused to clad the new structure. An excellent idea, especially with the current focus on the drive to net zero.
Yeah, it's going off to get cap and split, so not the easiest material to work with, but yeah, I think we'll probably do that around the same time as we move into the landscaping season, so that we want the temperatures to come up before we start putting cladding and using mortar. So.
Yeah, I'm sure, as I mentioned as well, but the local quarry, it's quite a lot of boxes getting ticked here in terms of the carbon footprint, etc. So it's good to see projects, not just starting. I know we do it elsewhere, but it's more and more becoming a noticeable thing on sites, isn't it? To think ahead of these things. Yeah.
Yeah.
All right. So another one from Russell says, thanks, Robert. Compact fill with geotextile rather than piles. Nice one. Cheers.
Yes, much easier, obviously.
Yeah, piles are not that popular with the residents being so close either. So yeah,
absolutely, yeah, yeah.
There's a lot of there's a lot of difficult work to undertake beside the residents, and as the communications manager, it's the team that is largely the team that maintained the relationship there. Very good relationships. Some difficult issues to cover, but from everybody in the team from foreman up was engaging with the residents and working with them. So yeah, a lot of effort put into that by the team.
Yeah, I thought you were going to say difficult individuals there, but you changed it to difficult issues. So
I did, yes.
Strategically. Okay, comment here from Callum saying, thanks for the presentation, really good. Do you have any more information on the initial thinking behind using the granite from the existing structure and how this was signed off from a design perspective?
I don't, but I'm aware that I think cladding's not, I'm speaking from what I've heard, is that cladding's not common on railway structures, and I think it comes from the road consultation. So this is a railway bridge, but it's been done under, if you like, under the authority of the road scheme, and the road scheme consultation, a lot of stuff that came out of that road scheme consultation has fallen into this contract. So yeah, so I think the cladding is something that's come from the road scheme consultation rather than consultation that Network Rail or BAM carried out with the community. Callum, do you know anything else about the choice of I think it was specified granite, but I think we opted to use the existing for that purpose.
Yeah, I think they specified local granite, and I think there was an issue getting that. So they went to a couple of suppliers, and they came back with some things that were close to the existing structure, and then the decision was made to actually just use the stuff that came off the old bridge.
Yeah, and there's a comment there from Chris McCafferty as well, because Chris was involved in some of that dialogue.
Yeah, excellent. Okay, I think that's all the comments or questions on the chat. What I'll do now is I think I've hit unmute all, so I think if we'll throw open to the floor. If you do want to ask a question, just unmute yourself. I think it was locked up till now, so hopefully if you do wish to do so, you can just unmute yourself and feel free to ask any final questions.
If you stop the recording, you can have a more open conversation with the if you wish to.
I was going to keep it running until the vote of thanks was done, and then there might be some final questions after that. But yeah. If anyone, feel free to ask any further questions.
Hi there, Greg. It's Jim Watson. Since Tom's not with us tonight, I suppose I need to step in and fill that gap. Firstly, thank you, Rob and Stuart, for an excellent presentation. I thoroughly enjoyed it. But a question for Rob. Every day's a school day, and something you actually brought up tonight with the conflict between the Civil Standard 177 and CRT management. Perhaps this is something we should be looking at the design stage at IDCs. Something I'll certainly take on board if I'm in that position in the future is that it's a question I'll ask IDC so that we can hopefully go forward without the sort of last minute problems that you had to resolve.
Yeah, I think the reason it caught me out, Jim, is that in most other instances where we've done bridges and stuff like that, whether it was the West Coast Main Line or the North of Perth, there isn't enough access midweek to actually do stressing or anything. So it's never happened to me before. normally, you know, you're 5, 6, 7 days later before you can get back in with enough time to do stressing. So I think that's why it caught me out. But I kind of should have forecast that it was going to happen.
No, it's something you probably normally wouldn't think about. Something I've not thought about in the past, but it's a lesson I'll take away from tonight and apply to future projects. Clearly, say with the plan to weld in the following possession, it was opened up with a TSR on it, yeah?
It was, yes. It was opened up with a 50. The 50 stayed on until 6 days later when the 1 week follow-up tamp was done, and then it came off.
So I suppose given the time of year, that would, I suppose you could look at that as a mitigation as far as CRT is concerned.
Yes, that's it, yes. It was. I mean, obviously, we're still issuing the CRT daily reports for the site, and I think the CRT watchman now is up to 48. It's one of my little bugbears that there's no way to get out of issuing daily reports every day, you know, and at 48. We don't even have to take stillage temperatures until the forecast air temperature is 30. There is no way that, you know, there's ever going to be anything required for CRT at that site, whether it's stillage temperatures or mobilisation or anything. But you still have to go through what is pretty much a 6-month process when it's on a line that's pretty low traffic. You know, your temperature line goes up 0.5 degree per week. You know, you end up having to issue daily reports for 5 or 6 months, when if there was some process or procedure in place that, you know, you could do a risk assessment at the start of that, there should be a way of getting out of it, I think.
Absolutely, Rob. I very much agree with you there. But of course, you'll have a standard. There's a one size fits all. Yes. You're certainly highly unlikely in January or February or March. Well, maybe March to get any particularly high real temperatures up in the Highlands.
Yes.
As part of your CRT monitoring, I sort of appreciate that we have a site that's very much remote from your bases. Are you using remote monitoring, or is it based in a stillage somewhere?
No, if I had to, we've got the Datum remote monitoring box. We've got one of those, so if we had to, we could just put it onto the rail, and then it's got a built-in Wi-Fi transmitter and everything, and it reports the readings automatically to their server, and I can access it from there.
Right, great stuff. Thank you very much, Rob.
No problem.
One more question from me, I guess. With the being snowing, I suppose there was no risk of the tamping being at risk at any point, was there? Were we getting close to any too cold to tamp, or was it miles away from that?
No, it wasn't cold enough, Greg. Yeah. We did kind of review that in a day or two beforehand, but it was no, it wasn't there. It was still was mostly above zero, even though it was the wind chill that was making it cold.
Yeah. Okay. Yeah.
Not much above zero, you know. I think it pretty much sat constantly around about 1 or 2 degrees over the full 78 hours.
Right. Yeah. Okay. I think a last call for any final questions from anyone at all.
Greg, it's Gordon Robinson here from Network Rail Construction Manager on the job. Just referring back to a question that was that was put to Stuart, but whether it was the go or no go on the Friday evening. From a kind of Network Rail point of view, we were looking at obviously looking at other areas in the network which were being battered, and our main concern that evening was having passengers stuck on a train that may have struck or been struck by trees or fallen debris. So that was the biggest concern that we had that evening prior to the decision to go or no go, and also trying to get the Highland the sleeper off to London, and just making sure that the trains were left in the right position for us at the end of the possession. But as I said, the biggest thing was our fear was that something would be stuck in the possession prior to it coming on, and having a train kind of disabled, and it would hold the works back and push the works back. That was our biggest concern. But once we established that was going to happen, and control had pulled back the trains and kind of cancelled a lot, then we were quite happy that we was going to go ahead. So that kind of gave us a bit of confidence. Once the sleeper headed south, we had one more train south north, and we were quite happy just to push ahead with it.
Yeah, thanks for that. Yeah, it's an extra thing. You know, we not everyone thinks about is, you know, it's not just the works itself, it's the prior to the works and the operational network, as you say, making sure everything's clearing out of the way before the work even starts. So yeah, it's a lot to think about. It's tough, and especially in a location like that, I'd imagine, because you have all the go-no-go criteria, and the weather can just change so suddenly, and especially over a long 7 to 8 hour period. So it can be quite a fraught time when the weather's not looking good as to whether the job's going to make it or not. So yeah. Okay, I think I've got another question here from David Maxwell, who is asking what was the overall project budget?
I don't know that one. I don't know if Stuart does.
Okay.
I think in total, including the culverts, I think it's just under 9 million.
There you go. Yeah.
That's including both culverts and all the other associated works with it, the road works as well.
Yeah. Excellent. All right, I'm going to do a final call for questions before ask someone to give the vote of thanks. So we'll just give it 10 seconds or so. Excuse me. Okay, as I say, we'll go for the vote of thanks, and I'll stop the recording. If there's any final thoughts or questions anyone has, we can hang on for a slight bit longer if you want to ask Stuart or Robert anything at all. So at this point then, I'm just going to pass over to Andrew Anderson to give the vote of thanks. If you're okay with that, Andrew?
I am indeed. Thank you very much. Well, what a great talk. Thanks very much to Robert and Stuart for putting it together, and for Callan, who jumped in at the end to deal with some of the detail. I've watched this one go in the general press, and it's really great to have such a detailed presentation out about it. Interesting to see how you can de-risk some of the biggest things in terms of building the bridge offline in the summer and using a crawler to put it in, but you're still reliant on huge cranes to do the wing walls, and you've still got problems with the temperatures if the clips won't come out without a large hammer. So some things don't change. And it was also nice to see, I think you said you were a wee bit concerned about the photography, but they were a cracking set of slides, and I think you're well set up for your Christmas card next year. So if you'd all like to join me to say thank you in the usual way, please do.